Let's solve the system of equations using the elimination method. The elimination method is a lot like the substitution method in that we have the goal of getting to an equation that only has one variable in it, which makes that particular variable pretty easy to find. The difference is that we're going to do this by doing a combination method. We're going to put these two equations together in order to make one of the variables disappear. We're looking for an opportunity to do that here, and really both variables give us that opportunity. There are two ways we could go. One way we could go is to multiply this first equation by 4. When we do that, we get 8x minus 4y equals 4. Then we can add the second and third equations, and when we do, we won't have y in the equation anymore. So that's one way to proceed. Another way to proceed would be to multiply the first equation by negative 4, which would give us negative 8x plus 4y equals negative 4. Then we could add the second and third equations, and there wouldn't be any x's left. It doesn't matter which way you go. You should get the same answer either way. Let's go ahead and finish the problem using this method. So after doing this work, we have 8y equals 2. Divide both sides by 8. Y is 1/4. Now that we found out that y is 1/4, we need to figure out what x is. Well, let's put it back into the second equation. So we're going to have 8x plus 4 times 1/4 equals 6. Notice that all I've done is replace y with 1/4 in this equation. 4 times 1/4 is 1, so 8x plus 1 equals 6. Subtract 1 from each side, we have 8x equals 5, and divide both sides by 8, x is 5/8. So we propose that our solution would be 5/8, 1/4. Well, we know it's going to work in the second equation, because that's where we put the 1/4 in and then discovered 5/8. So the real question is, will it work in the first equation? Let's find out. Take 2 times 5/8 minus 1/4. Well, 2 times 5/8 is 10/8. 10/8 reduces to 5/4. So we have 5/4 minus 1/4, which is 4/4, which is 1. So that works. And our solution is correct. 5/8, 1/4 is the point where these two lines intersect. Just like in the substitution method, in this case we have a consistent system. We got a nice, neat, singular solution. It doesn't have to be that way all the time. If in your work you generate an equation that simply can't ever be true, something brilliant like negative 3 equals 8, well, you've got two parallel lines on your hands. There won't be a solution in that case. It's also possible that you could generate an equation that could never be false. If that's the case, you have a dependent system where the two lines are actually the same line. You'll get something silly like 3 equals 3. No number in the world can make that false. When that happens, you have a dependent system. There are actually infinitely many solutions. So there's no point in continuing your search. The two lines are actually the same line.